Okay, hi. We are from section 4, group 3. So, this is our presentation for design of suspension insulator for 132 kV system. Okay, so my name is Amirul Adif bin Shariman. My group member is Muhammad Amir Amirul bin Alias, Muhammad Farhan bin Yusuf, Nur Aziatul Akmal binti Muhammad Kamal. Okay, so the introduction for this project. So the conductor, we know, is the one of the most important element since the majority of financial outlay. So based on the result, by selecting the right conductor material and size is critical. So the conductor material used to electric transmission and distribution must meet their following requirement. So their requirement is number one is strong tensile strength to the withstand mechanical stress. Number two is electrical conductivity is high. Number three is low specific gravity resulting in a low weight per unit volume. Number four, a low cost that allowed to be utilized across the long distance. So for the suspension type insulator, the cost of pin type insulator rise rapidly as the operating voltage increases. So this insulator is not cost effective over 33 kilovolt, and it may seen in this figure, which is commonly used for high voltage more than 33 kilovolt. So they are made of a section of glass disc by joining metal link in the shape of their string. And the conductor is suspended from the bottom end of the string, which are fast to the tower cross arm to the other end. Each unit this make a withstand model voltage such as 100 kilovolt. So the working voltage determined by the number of this in their series. Okay, so for the problem statement, insulator pollution is a one factor that contribute to poor electrical performance of the overhead transmission line. So their environmental effect, which is the final distortion, moisture ingress, surface area contamination, and high wind load. So then all the contribute to insulation failure. And salt water also can corrode the disc insulator pin material to reduce their tension rating. Okay, and then the distribution of insulator surface can cause the serious incident. So the safety of civilian in the surrounding are in a risk category. And a polar insulator also increase the risk of lightning, making flashover more likely. And then the insulator is risk of tracing whenever when is discharge, which is external flicker, occurs. The phenomenon in which physical indentation or scar appear as a semiconductor, which is track that cause electric arc in the surface of the insulator. So it highly contaminant insulator is still used. There will be a significant number of casualty and maintenance will with fee will rise through the year. Okay, so the objective of this uh, project has been formed as follow, which is the first one is to design 2D and 3D the suspension insulator model that appropriate for 132 kV by using the AutoCAD software, and then to number two is to simulate the performance of insulator by using FEMM software. Number three is to conduct high voltage tests by following a technical analysis of the performance of the insulator. And then for one is to be able to group work effectively in a given time. Okay, so the scope of work is design 2D and 3D insulator by using AutoCAD software, simulate and analyze the normal voltage and electric field distribution on the insulator by using the FEMM software. And the last one is a performance analysis of design insulator by using FEMM software. Okay, so this is our report by using the program and the FEMM. One of the key to achieve the objective will be creation and 3D suspension insulator model that are appropriate with the 132 kilovolt. In additional, the performance of insulator will be simulated by using two pieces of software. Okay. In addition, one of the result of this project will be provision of technical analysis performance as well as the study distribution of the high voltage and electromagnetic field within the insulator. Okay, so lastly, but most importantly, the goal of the project is to facilitate the productive group work that is capable to resolving this height stress problem in the given time. Okay, so this is a concept design for insulator, glass insulator. So AutoCAD is being used to design the glass insulator for 132 kV transmission line in 2 and 3D drawings, and then design this type of insulator is using criteria where we discover on the research paper and information that we found in the internet platform. And then material also have been investigated in order to make their suitable for 132 kV transmission line as well as polluted environment. So in the pictures on the left side, this was a conventional glass insulator, and in the right side is a new design from our company. So which is their material can handle more stress than the other conventional stress, and then it can prevent the dirt, like all the accessories things such as a water and dirt. Okay, so this is our second and third, 2D and 3D drawing for is our insulator, which is make. Okay, so this is our 2D and 3D drawing for one disc of the insulator. So this is a top view and drawing process. On the left side is a top view for the insulator in a drawing process, while the right side is a after the rendering process. Okay, and then so for create this insulator, glass insulator, where we need to have the calculation of their maximum range and their creepage clearance. Okay, by calculation that we already made. So calculation of clearance distance have been designed can be calculated by using the formula that shown in this figure. Okay, so 132 kV divide 132 kV times 0.002, we can get the value of the creepage clearance, which is 2640 millimeter. And then for each gap, continue for the next step, which is to build the design of this glass insulator. The first thing that we need to identify is their calculation for their creepage clearance. So maximum of insulator is 1540 millimeter, and for the creepage clearance we can find by using 132 kV times 0.002, which we get 2640 millimeter. And then for the each gap of insulator can be calculated by 2640 millimeter from the current distance formula, and then we divide by the 8 disc, so we get the each disc creepage distance is equal to 330 millimeter. Okay, so to find the number of discs that should be consumed for 132 kV is by using on this formula, which is the number suspension glass that can we calculate to get the required of each disc. So by using this formula, we can get the total of each disc of this that can be consumed is 8 discs. Yeah.
Hi, Assalamualaikum. My name is Muhammad Fahmi Yusof. My matrix number is CE190029. And today I will continue to explain the technical summary of FEA simulation software. So for the FEA simulation software, as you can see, it can impact the various of situation, which is the stress, condition stress, the vibration, buckling, fatigue, creep, and heat. On the insulator, the design can be tested using this FEA software. And the second one is it helps, the FEA software helps to resolve challenging structural engineering issues that are subjected to static and dynamic loading condition. And the third one is it can model the effect that harsh condition in the real world will have on the insulator design by including the FEA into the product development process. So that's all for the technical summary FEA simulation. I will continue to the next slide. As you can see, this is the block diagram of FEA simulation software. So this we have three phase in this flow of the FEA simulation. So the first one is the insulator design. So we design the insulator is using the AutoCAD software. After we design the insulator using the AutoCAD software, we identify each coordinate. We identify each coordinate, and as you can see, the second phase is the front page of FEMM software. So this is after we open the FEMS 2.4.2, we create a new problem which is an electrostatic problem, and then after we click OK, it come out like this as figure general properties. So this figure shows that the time that we have to identify the parameter and the insulator parameter of the insulator and the coordinate of the insulator, and then we uh, key in their properties and materials and the properties for the insulator itself and the experiment test, and then we design the coordinate. After we identify the coordinate and the properties, we design the coordinate, and this is the load of the coordinate of this insulator for the insulator. And after that, we run the generator mesh, and this is the second flow of making a FAA simulation in the insulator mesh, and come like this. We have to make sure there is no error. Before that, we have to save first, and then we have to run it in the simulation software, FEA simulation software. And after that, it come up with the end of the phase, which is the result that we can have the data collection here. The field intensity, the voltage of the insulator, we can monitor it, the all of the uh, leakage or the magnetism or the electrolytic of each corner of the insulator. Uh, so as you can see at the bottom of the block diagram is the general block diagram for FAA simulation. So first one is choosing the new model of insulator. As I mentioned before, we are using AutoCAD software, and from the AutoCAD software we design the insulator, and the insulator, this is a single insulator. We have the strings insulator. We have eight uh, eight insulator that I've connected have connected in strings, and after that in the phase 2 we apply the parameters and the boundaries condition, as I told previous. So this is the phase 2, which is we apply the parameters and the boundaries of the condition for the insulator, and in phase 3 we apply the load in each section of insulator, which is the uh, porcelain or glass or the conductor or the air and the water droplet. So that's the water droplet. Also the our test for the wet air condition, and the last phase is to study a processing insulator, which is this phase, which is as I told before, this is for the data collection for all the intensity of magnetism or electrostatic in the insulator. So that's all. I think that's all for the block diagram of FEA simulation software. And thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azatokma binti Muhammad Kamal, and my metric number is DE190154. I will continue for the analysis and discussion. So this is the single disc superposition glass insulator for dry condition, and this is for the wet condition. So this is the construction of this, a single disc. This is the pole and this is the pin. And this is our glass insulator right here. For the single disc, we set the iron at the bottom is as a high voltage, which is 11 kilovolt. So that the iron at the bottom, which is the pole, is ground, which is 0 volt. So this is the construction of the wet condition. At the wet condition, we add the design with water drop at here, which is the water drop at 20 degrees Celsius. So this is the construction between dry and wet condition. So this is the mesh analysis that had been done after we do the construction by using FEMM. This is the voltage analysis. So we set at here is 11 kV and up here is ground. So this is the voltage analysis. As you can see at here, the dry and wet condition, it have a little bit high intensity that the yellow colors. So which is at the yellow color is having a high intensity field, which is because of their angle at here. And FEMM constant that the glass is in 2D, so that after the pin it still has a glass, but in real life they are having a curve inside. They have a angle between pin and also the glass, so that magnetic field can't. This, as you can see, it has a little bit yellow colors because of that is having a uh, high concentration of field intensity. Okay, it's happened because of it's having a edge at here. Okay, now is the graph of magnitude of field intensity, as you can see it here. This part having the high field intensity, which is at here, and some same goes at here. This is at the both between the glass and also the both the yellow color. It's reached around 400 volt per millimeter. So as you can see, the field intensity between dry and also wet, if have a water droplet, which is at here, this is the location of water droplet. Because of the water droplet, the field intensity, the concentration of field intensity at there is fluctuate until reach 100 voltage per millimeter. So for the case study condition, we have a three condition, which is dry, wet, and also the continuation, which is at here I have stacked all 8 pieces, become one superposition glass insulator, which is having a 8 disc. So at the dry condition, just having air, but in wet condition, we add the surface of glass having a water droplet, which is a little bit water droplet, and same goes to the contamination. We add at here a little bit of contamination. This is the construction of insulator while using FMM. This is the mesh analysis of it. So as you can see, setting as a 11 kV divided by 3, which is 7.6 kilovolt around that. So this is the voltage analysis. So this is a magnetic field intensity. As you can see at here, same just like the single this one. It has a little bit high concentration between the pin and also between the bolt at here. Okay. Every bolt have, and same goes to the condition of wet and also the contamination. Okay, but for the magnitude graph, as you can see it here, for the dry one, each of the rate of the T's is around 1.3 volt per meter, the field intensity. But when we add the water condition, which is we add the droplet at here. So as you can see at here, it has a fluctuate here, here, and here is around to reach 200 volt per millimeter, 200 volt per meter. Okay, same goes to the contamination. Okay, at the pin at here, it get reach until 500 volt per meter, and each each part of this have been put the contamination have a fluctuate until reach around 200 or 250 volt per meter. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Amirul bin Alias. My matric number is CE190197. Today I would like to present for my part on the HV testing proposal. In this HV testing proposal, we need the first safety risk assessment. The title of the experiment or test that we are doing is destructive test using the method of tracking test. Then we also need the experimental declaration that need to be signed by the student and the supervisor or the lecturer in the laboratory. Then the method used in the destructive test using the method of tracking test. The purpose of experiment is to test the durability of glass insulator. The equipment used in this circuit or test is 0 to 240 watt AC power supply, HV transformer, overcurrent relay current box, main control box, data acquisition, lab software monitoring, shunt resistor, overcurrent relay, HV relay, contaminant water, peristaltic pump, filter paper, sample and thermal camera. The procedure used for the test is: first, after the glass insulator is cut into a few pieces, it's been washed with the isopropyl alcohol and distilled water to remove any sign of dirt or oil. The insulator was sprayed with the solution of NaCl and distilled water to simulate saline pollution found in the coastal location. The electrolyte was delivered of a constant flow rate using a peristaltic pump. Between the top of electrode and the sample, filter paper was utilized to act as an electrolyte reservoir, ensuring appropriate electrolyte flow along the insulating material surface. Fifth, if the specimen was positioned such that the electrolyte ran down as close to the specimen centerline as possible, then the voltage stress is applied across the surface of the glass sample using as high voltage transformer. Then need the risk assessment for the destructive test. This risk assessment contains hazard and possibility consequent from this test. As shown, the hazard is the electric shock from the higher voltage maximum 11 kV alternative current and fire. So risk assessment is between 1 to 5 if low, 6 to 8 is medium, and 9 to 25 is high. And the recorded chemical uses with this experiment. Hazard checklist. There are few type of hazard that are been shown in this experiment, and the hazard present in this experiment is electric shock, fire, and high temperature. Then production of dust or fumes. Okay. Then this is the code of conduct. The figure 1 show the equipment arrangement for the tracking test. For the tracking test, surface discharge activity connected with the flow of leakage current on the insulator surface lead to electrical tracking. In this test, glass insulator is being divided to 5 and being cut between 6 cm long and 3 cm wide. Each glass insulator have different stick start from the less thick to the most thicker in the long term. Arch formed by the thick surface discharge phenomena burn the glass insulator material, resulting in carbonized stripe. This test look at how well electrical tracking works by looking at the leakage current and carbon thread growth to investigate the overall performance of surface tracking properties and electrical tracking and erosion tests utilized in the inclined plane tracking method of perform. Figure 2 show the example of burning effect of the surface of the insulator when the leakage current is being applied on it from tracking test. It shows that different thick of insulator have different burn effect. This is because less thicker insulator surface will allow more leakage current flow on it and produce more heat, and also will produce large burning effect. In conclusion, there are several conclusions that can be made from the destructive test use method of tracking test. First, experiment procedure need to follow wisely to avoid any necessary accident. The main reason doing the tracking test is to test the durability of surface of insulator. In general, the thicker the insulator, the more durable it is. It's because leakage current can flow at the surface of the thicker inductor less compared to less thick insulator. Leakage current will produce high temperature that will give effect to the surface of insulator, then will burn the surface of insulator. Last but not least, good material and good thickness will make the insulator will last longer and can be used for the long time. That's all from me.